most of what I'm talking about today I'll be presenting without any PowerPoint slides. I'm going to be using my tablet PC pretty much like a chalkboard in a real classroom. So what are we going to talk about this week? The focus this week is on noise and filtering. Very basic. I think that you got a jump start with last week with Scott, who gave you an overview of all optical systems. He gave you an introduction to OptiSystem and really kick-started you into it. And now I'd like to get down in the trenches a little bit and talk about some fundamental issues about noise and filtering effects, which of course are present in all communication systems and all optical communication systems. And we'll just be giving you some formality, some discussion about what exactly is going on behind all these simulations. So we're going to try and tie together the theory and the simulators. And very, very important is what we're going to talk about today is validation. So we're going to start by giving you some theory. So to take theory and use it to validate. So we turn to numerical simulations because our theory is not enough. Our theory cannot describe everything. And there are certain effects that we, instead of using theoretical analysis, have to do numerical analysis. However, the theory is still valid in certain regimes of operation. So when you're writing code, one way of validating is to reduce the operating parameters for your simulator into areas where theory should be accurate, and to see if your simulator does give you what theory tells you. So this is sort of the theme of the homework for this week and the thread that will be carrying us through the noise and filtering. We should see what the theory tells us, and then we'll see how it might diverge from that as different effects. In the theory, we'll be developing equations, and there'll be many simplifying assumptions. And when we violate some of these simplifying assumptions, we expect that the numerical simulation will be giving us results that are different from the theory. And so we hope to see these effects as we're talking about it. So when we're talking about noise and filtering, we're also going to be taking the theory and letting us predict performance. And of course, when we talk about performance in a digital communication system, there's really one key figure of merit above all others that tells us about the performance of our system, and that is the bit error rate. So we'll be focusing a lot on how to calculate the bit error rate for a system, known of course as BER. Typically we'll plot this versus many different parameters. There are of course many other figures of merit of interest: spectral efficiency, throughput, many network criteria. But for today, for this week, we'll be concentrating on bit error rate. So in particular, in the first half of this week, I'll be talking about the theory, the sources of noise, the modeling of noise, how we take these models into simulations. And then the second half on Thursday will be more on filtering.